Hi there. It's another hangout. This is the, oddly enough, on the title, I'm going to be doing that topic about light and waves, and especially electromagnetic waves. But as I said in the description, as far as physics is concerned, there's two kinds of waves, mechanical and electromagnetic. And so obviously we're going to be looking at the electromagnetic waves. And that's because that's part of what light is. Light is an electromagnetic wave, just a part of the spectrum of frequencies. And we have to understand waves in general before we can even understand electromagnetic waves and light in particular. So basically a wave is the result of a vibration or oscillation, which is, going back and forth, which is any kind of a periodic motion. So something that keeps repeating within the same bounds, the same motion, back and forth, okay? So a mechanical wave is a disturbance caused by the distortion of some kind of physical matter, such as sound through air or water. And we can see the basic concept by watching a drop of water in this video that I'm hopefully going to at least show the video, or, no audio on. It typically doesn't work. If you hear it, that'll be a miracle or something. But this is the slow-mo, guys. Why I put the disclaimer up so I wouldn't get a copyright on it. But pretty interesting. They just wanted to look at surface tension. And look at what the drop does. It's just very short distance, didn't have a lot of force on it, but it sits on top, and then watch it for a few seconds and does something really unexpected, which, look at that. It just changed its size in half. It shrunk by half, thereabouts. And it isn't done yet. Going to do it again, until you can't see it anymore, and it just blends right in. And you probably can't see it. I don't know why the video has to be so small on that page, but I don't know. I guess I just don't have this set right, but you get the idea. And you probably couldn't see it, but there were a lot of other little tiny droplets coming off of there that did the same thing. But the thing is, this is showing waves that were caused as soon as it dropped in the water. You can see the rings coming out. Everybody's seen that. You drop something in the water and waves come out. Well, why does it do that? I mean, the drop happened vertically, right? So why are the waves going out this way? And that's just a fundamental thing about the way nature behaves, and when it has some medium that it's going to react to a disturbance that way. So we can also visualize that with the next image. I hope it will come up, that none of these sites are down. This is basically what's going on. You drop the stone or the drop of water vertically, and the water is like a spring. It bounces up and down, but it's bouncing up and down straight. Okay? But because it's continually applying this force, although it gets less and less as it goes because it's using up energy, and so the distance that it travels is going to get shorter and shorter. This is, of course, just a drawing, and it will just keep going like that forever. But the point is that that little box there is going straight up and down, like it's on, on a string or spring, and that's kind of what's going on with the water. But it happens over a period of time and causes a disturbance that goes out in all directions, and that's where you get the waves from. So by definition, for something to be a wave, it has to have three components: amplitude, wavelength, and frequency. So now we're going to look at the next page that talks about that. And I suppose I could try to blow this up a little bit. Different kinds of waves. They carry a little energy or a lot, short or long, rare or frequent, fast or slow. Different types of waves. They're not all electromagnetic, like I said. There's sound waves, light waves, X-rays, microwaves, ocean waves, but they have those three properties to be waves. Okay. To understand, to help represent, they have this graph here. The x-axis is going across. Okay. And that's the resting position, or usually it's at 0, though. I'm just showing the bottom of the box there, but 0 is your resting place of the medium, whether it's water or whatever. Water's the easiest thing to visualize. That's at rest, but the y-axis, of course, is height above and below that resting point. And I will show you, they mentioned a tightrope here. I'll show you a rope later. It's pretty cool effect that it does. But the y-axis is the vibration. That's what a vibration is. It's a wave. And so this little dot here is just going straight up and down like that spring was doing. But because of the time element and the fact that the medium that is being disturbed is reacting just that's how it's programmed to react, it's making waves. And those waves have a certain repetition. Peaks, the highest part are the peaks, the lowest part are the troughs or valleys. And the period of a wave, or the frequency, or the hertz, is from one complete circuit. One, like from here, if you start from the top till it goes to the top again, okay? Or if you usually in math, you would start at the resting point and then go all the way back until it goes up, down, and back to the resting point. That is one cycle. A journey's wake. So this is what they do in math to visualize what a wave is. It has those 3 components. And then they explain what amplitude is. It's the distance between the resting line, the 0 line, and the highest peak, which is going to be the same because it keeps repeating, but that's the amplitude of a wave. Amplitude in sound waves is the volume. Okay, that's just how it is expressed in a sound wave. We call amplitude volume. And that will determine the strength of that wave. How far it moves determines how far a speaker will move or your eardrum will move, because it's actual energy pushing something. And that's how that's what vibrates to tell us what the sound is. And then we have the length of the wave, I already mentioned, about from one peak or one trough to the next. And then the frequency is how quickly it goes through that cycle. Okay, cycles per second, or hertz. You see this Hz is hertz. That was somebody's name, German guy's name, Hertz. That's why they call it that, but it's cycles per second, or CPS. So different things in the electromagnetic spectrum have different frequencies. That's, we have short to long visible light between blue and red, and then we have infrared, ultraviolet on the other, more extremes that we can't normally see. And then we have X-rays, microwaves, all sorts of things. And then they talk a little bit about sound here, about how frequency is the same as in music is called the pitch. We also have the shape of the wave in music, which is the timbre. And by controlling the shape, you control the type of sound that it is. But pitch is the frequency. So I'm not going to go too much into that, but you can show visually what frequency looks like. And that's how, like I said, in the course of time, how long it takes to complete one cycle. So you'll see this if you have an oscilloscope or something like that will interpret signals as waveforms, usually a sine, it could be any kind of shape of wave, but we're looking at a sine wave here. Higher frequency will be shorter together, lower frequency will be farther apart. So far we've seen with amplitude and frequency and things like that, especially with amplitude, hey Mark, you cannot have a wave without a medium, which is a big deal, okay? You cannot have a wave without some medium doing the waving. It's caused by something other than itself, usually, in at least this kind of wave. There's different kinds, we'll see. But the point is that there must be something that is being disturbed and something doing the disturbing. Okay, so those are the basics. And technically, a wave doesn't travel. Okay, the medium goes up and down, But because all the particles in the medium are connected, it's got a delayed reaction kind of, and it looks to us, we perceive it as movement, but it's really not movement. It's frequency, and the wave is not traveling. It's just that everything is connected. When one part isn't disturbed, it all gets disturbed, but it takes a little bit of a delay depending on how far it is from the point of disturbance. So, but even though waves technically don't move, we still know from experience, like if you've ever stood on the seashore and got hit by a large wave, it definitely has a lateral force to it. Okay, and there's reason for that too, is because of just the physics of it, that it's rising up in an arc, and your body isn't able to just, it's too heavy relation to it and all that to just ride on top of the wave. You do some very large waves as you're out at sea. You're not by the shore, because the shore complicates things. And so that's why you would feel that force. So it has to do with how the medium reacts to the disturbance, as whether there's going to be that horizontal component of force that you can feel. But basically, waves are chain reactions of usually, uncountable interconnected particles reacting at different times. And the sequence of a reaction is what we experience as a wave traveling. So when one part of the medium, whether it's water or whatever it is compressed, other parts have to compensate by expanding. And so that's where you get that lateral movement. It's like a spring, like I showed when I first started the video. And it will keep diminishing, just like any wound up spring, like in a clock. It loses tension and it loses momentum, and it has friction and heat and all those things, and it will eventually slow down. So now we're going to look down here at the properties of light. You saw that little headline there, or title there. It says, what does sunlight have in common with x-rays in the doctor's office? They're both waves. That's all they're saying. This is a very basic elementary article, but that's, if you can't explain something to the average person, it's probably, it could be done better. Everything should be in real science explainable, modelable. That's the purpose of a model. The value of a model is not to prove anything in reality, but to explain a concept. That's what models do, and drawings can serve in that purpose. Light is a particular kind of wave, an electromagnetic wave. They're different than the mechanical waves we've been talking about. Okay. Light is an electromagnetic wave. Light from the sun travels the earth through the vacuum of space, they say. This is a standard cosmology website. We'll get into more of that about vacuums in a bit. But you're constantly surrounded by all sorts of rays, but this is basically what an EM wave is, electromagnetic EM, okay? So you've got the direction, the wavelength going this way, their arrows going that way, so they're going left to right. And then with the electric field that it produces because of the movement, it's going at a right angle, kind of this direction, the shaded parts, okay? So these are different kinds of waves. They're always at right angles. The direction of travel is a right angle to the field that it produces as it goes along. So this is electromagnetic. Okay. Now, if you look at definitions on physics pages, an EM wave is defined as one that transfers energy without also moving mass. Okay, and its two main components are at right angles to each other, like I just mentioned. And let me get you a different illustration that will help to show that. I thought this was pretty neat. It's got kind of little arrowheads on which way the green part is going. But also the blue part is the right angle. Remember, I just showed you that, if anybody's actually watching this stuff. That blue squares kind of are the magnetic field at a right angle, and the waves going up and down are the actual, the main wave that we think of, the electricity. So that's what a wave is doing, but there's a medium waving, but yet electromagnetic waves aren't moving anything but energy. So it's kind of weird, and it gets worse. So I mentioned about the rope before. You know how if you hold one end of a rope and start shaking it up and down, you get kind of an S shape like that. Okay, so, but what happens if you move it in a circle? You've seen people do jump rope and things like that. But this is pretty neat. And sorry, it's not bigger. I don't want to do full screen. I'll mess up my computer or something. But yeah, we haven't talked about the Discord thing, Mark. Sorry, we'll have to. You know, we haven't done a Blood Always Finds Its Level hangout, so we were going to do it then, but Pillbox had to work. So anyway, look at that. That's just neat. The way the rope is being twirled around looks clockwise from this angle. And let me show that again. It's making kind of what you would call a standing wave. If you ever heard of a standing wave, this rope is flexible. You know, it's not a rigid object, but you can see that it's making these peaks and troughs. Okay, and just by spinning, because it's a flexible thing, which is elasticity, the fibers in the rope are all connected together. The particles, if you will, in the rope are all connected together in a straight line, but they're being agitated in a motion that is not, you know, going forward or back in this kind of wave. It's going up and down some in the previous drawings, and in this one it's going in circles. So it's just neat that one line is doing this pattern. It has to do with frequency. You know, you can change the frequency, how fast it's spinning and so forth, but it just makes a really neat effect. So I'm just trying to think of ways to help visualize. And there you can see the spiral, what's actually going on. So we can see when it comes to waves that we have to have timing and an elastic medium that's all, you know, all the little bits of the medium are connected together. Okay. I don't know how else to explain that, but it's just as a rope or a spring is one thing. You know, a spring is a spiral piece of metal usually, and the rope was one line, you know, of fibers. But depending on how you disturb that and you repeat a pattern at a certain rate, you get a wave. So timing and elasticity and connection of everything involved in the wave in the medium is what makes a wave appear. But EM waves don't move mass, like I said, and they don't disturb a medium. So how can they be waves? That's the question I'm getting at. And I'm not necessarily promising an answer. I just raise questions. So the best physics consensus I could find is that there simply has to be a medium in space, which they call quantum medium or quantum fluid, which is really just a fancy name for ether. That doesn't necessarily mean they're right. It's just the main guess at the present from what I could find. So some kind of medium, some kind of thing that waves, medium that's disturbed, that causes a wave and behaves like a wave because there's some kind of connection, but they can't find one with electromagnetic waves. So it's kind of a conundrum for them too, not just for me, but for anybody. So, but the thing is, we have things, when it comes to a vacuum especially, we have vacuum tubes. They used to be, 50 years ago, the thing before transistors were invented in 1940 something. So it's been more like almost 75, 80 years since then. But vacuum tubes are exactly what they sound like. They used to be, the predecessor of transistors and serve the same purpose, but they also produce light. So how did they do that? It's a vacuum. We know it's a vacuum. It wouldn't work if it wasn't a vacuum. So when they make these, they put certain elements inside the tube and pump out all the air, and you have a vacuum tube and you put electricity through it. It not only switches electricity around, but it also produces light. How is that possible in a vacuum, since a vacuum by definition has no medium? That's the question. To my best understanding, the response to this dilemma is that EM energy moves in fields, which, if you've ever watched Ken Wheeler, he says nobody really knows how to define what a field is. But we'll just run with that for a minute. They say that EM energy, electromagnetic energy, moves in fields, that these chunks or packets of moving energy are what they call quanta. Okay? So quanta isn't necessarily, I used to kind of confuse the two terms, particle and quanta. They are, in a sense, a type of particle, but not really when you get nitpicky with the definition, because particles are things like, things you can identify easily, like an atom or a molecule. But EM waves don't have those. But they do have some kind of bits, it seems, that's made of the same stuff, and they call them quanta. And to make it even more interesting, they move best in a vacuum. They move best in a vacuum, which means you should see light better through a vacuum tube than outside of the vacuum tube. Because the theory is they move better through a vacuum because there's no interference from anything else, like pesky things like air, to siphon off any of the energy as they move because of friction. Not sure, looking at the chat, about comparing to rare isotopes. I know they emit radiation. There's all kinds of radiation, but this is mainly I'm talking about electromagnetic because that's what light is. But I haven't looked into that, so I really can't answer you on that one. Anyway, they move best in a vacuum, these packets of electromagnetic energy, which they call quanta. But the problem is, this begs the question, I think, because the statement is basically, well, if it acts like a wave but moves through a vacuum, we must have some kind of quanta, or I don't want to say particles because it's really not as accurate a term, but packets of something, energy. Okay? Because they're trying to figure out how we can call this a wave. It seems to act like a wave in most cases, but it moves through a vacuum where there is no medium to disturb. So what can we account for that as? They think the only other alternative is to, like, shooting bullets out of a gun. Okay? Only those bullets are connected by a string somehow, it seems. I don't know. But anyway, we could propose that just because a medium, as a counter argument, we could propose that just because we can't detect a medium in a vacuum doesn't mean there's nothing there to disturb. I mean, just because a vacuum has no air or anything else you might be able to detect doesn't mean there's nothing there. As the famous Carl Sagan said, absence of evidence is not evidence of absence. Just because we can't detect it doesn't mean it's not there. But something is being disturbed, or it's not a wave. But they say it's a wave. They say it has frequency and amplitude. But this too is begging the question, this current argument, because we might say it acts like a wave through a vacuum, so there must be an undetectable medium. That's as much begging the question as the quantum theory. So they both beg the question. They're both trying to explain how these EM waves can do what they do in a vacuum and do it so well and prefer a vacuum when there's no medium, and yet everything else we know about waves has to do with disturbing a medium. So now the question of whether light is composed of particles or waves, which is what I've been getting at the whole time building up to this, applies to all electromagnetic energy, of course, because light is just a subset of that. But if EM energy, EM waves, is composed of quanta or packets, what causes the oscillation that we perceive as frequency? Why do these packets have a frequency? We know that when we drop the pebble in water, that we applied a force downward to the water, but the way it reacted was at a right angle to that. Again, I could go back to the pictures, but I think it's easy enough to visualize dropping a pebble into the water. It's dropping straight down, but the waves come out sideways, horizontally. which kind of messes with your head. But the thing is, if you can visualize that, you have to wonder what is causing an electromagnetic wave? What way is the disturbing force, the causing force moving? So what and why at a certain frequency? Hey, Will, good to see you. I hope I'm not mangling this too bad. So yeah, we're like I said, I'm not going to answer this question. I'm just raising questions. So let me try to continue with that, and then we can. I'd be really interested in talking about what you just said there. So, the thing is, we have this puzzle of electromagnetic energy, why it does what it does, and which is begging the question more, whether we assume that there are quanta, and if so, why are they being put out at a frequency and an intensity? And on the other hand, assuming there must be an ether that we can't detect. Both are, I think, in some degree, begging the question. So if I understand it right, EM quanta, electromagnetic quanta, are essentially their own media, which is, from what I read, what they're trying to say is, no, it doesn't need a medium because it's its own medium. And that's really circular to me, really begging the question. But they still, even then, if they were their own medium, they didn't meet the definition of a wave that I put earlier. Well, maybe it's more like what's called a longitudinal wave, which I haven't shown yet, and I will bring that up now. We've seen these other kinds of waves, but this is a physics classroom site. And what a longitudinal wave is like, if you were holding a slinky in each, one end in each hand, and you can stretch it apart and then compress it together. But if you stretch it apart and just kind of move one hand or the other back and forth, you will get this frequency. Even though the amplitude is not changing and no mass is being moved, really, it's a spring sideways with points of compression, points of what they call rarefaction, the opposite of compression, and that's your frequency. So it would seem, from that at least, that maybe electromagnetic waves are more like these longitudinal waves. And then they try to talk about what a medium is, and they say it's a substance or material that carries the wave, but there isn't any. They talk about different other kinds of waves, but this is a pretty cool animation of showing just what I was saying there about, man, that's awful small. Sorry about that. Now I got to roll down the page. I hope you can see that this longitudinal wave has a frequency, a pulse, and nodes in it that would be what you would count in that frequency of compression, rarefaction. And so that might be how an EM wave could be visualized. Okay. So let's go back to this article. I don't remember if there was something else I wanted to read in there, but they're saying, yeah, mainly that a wave transport energy and not matter. Which again, like, don't you need a medium? And they're saying, well, the longitudinal wave is its own medium. Okay, but according to the definition that I gave earlier, where it has to have wavelength, frequency, and amplitude, you don't really have amplitude. So technically it isn't a wave, but I don't know how, I mean, it seemed to be an accurate definition. So there's a lot of gray areas, it seems, in these physics documents. But they're saying their conclusion in this thing was a wave can be described as a disturbance that travels through a medium, like I said, transporting energy from one location to another without transporting matter. Each individual particle of the medium is temporarily displaced and then returns to its original equilibrium position. And I've gone, I don't know how many videos I talked about balance and the desire of nature to find equilibrium. I think I went into that mostly on the video Down with Gravity, where a lot of things can be understood if we know, just as a principle, whether we can explain it or not, that nature wants equilibrium. And so things happen because things are out of balance and they try to rebalance themselves. So that's the best I can do with that, with the definitions they gave me. But here again, with the longitudinal wave, let me roll back up to the slinky. It's up here somewhere. There it is. You still have to have, you notice something here is you can't have this happen without everything in that line being connected. Like the rope that I showed earlier, longitudinal waves also have to be connected. So it's replacing, basically, in the definition, the medium with its own connection of its own material, all the same material, because you can see on the top picture here, it's one coiled piece of metal that you can stretch, it has some elasticity. Hey, concerned citizen, Mark, I think I said hi to you. Some elasticity. So we've got kind of the components there, but the problem is with an EM wave, there has to be a continuous string of whatever EM energy is from source to destination. So in that respect, it's not like shooting bullets from a gun. The bullets are not connected to each other. But with EM waves, they have to be if you're going to call it a wave, and it's going to act like a wave, which it does. So this, if you picture nothing else but that, is telling you that an EM wave has to be a continuous connected string of something from source to destination. So this is the only sense that I can wrap my head around the idea of a wave being its own medium. But like I said, it requires all the quanta, these compressed spots, to be strung together. There has to be rarefaction between them of what? The EM wave itself, the energy. So, and even that has complications. Let's make it a little more gnarly, because it isn't gnarly enough already. This, I know it's wiki, but they actually had a nice collection of images here. And let me see if I can just run through them without looking at their text there. This one really doesn't matter to what I'm talking about, because this is about, people laugh, but it's rectifying waves. This is how you make a power supply from AC to DC. But there was the picture of, like I said, really nice images in this wiki page of waves going out from a central point. That was the first kind of wave I talked about, and the frequency and the distance between them. And there's waves, you know, it isn't, in nature, you rarely have a pure single wave. Okay, you've got waves canceling out each other. This has to do, this is why we have audio noise filters and things like that. And you want to get rid of the unwanted waves. It's also how, well, really basically how polarization works. If you wear sunglasses, they're polarized. They eliminate some of the unwanted waves of light. Not part of the frequency, but, you know, because people will say, well, it reduces the natural sunlight. It's reducing the angle. And it's kind of hard to explain, but it's really not the main thing I was getting at with EM waves. Anyway, it's a really nice gift that they have here for how waves interact and how they get complicated. Then we have different kinds, shapes of waves, and these are usually not found in nature. The sine wave is, the square wave is usually an electronic issue, so also with the triangle and the sawtooth. And you can hear these differences. My final project for electronics school was, I made a synthesizer, a really crude one, but I need a synthesizer, and I basically just drew the wave. And this is primitive stuff. We're talking back in the 80s. Okay, that I had the barest minimum early IBM PC using assembly language programming, and I had to put hexadecimal code to draw these waves. So it was a pain, but you know, I did decent on the project. So anyway, I could draw any shape I wanted, and whatever shape I drew, you could hear the difference. That's what timbre is in music. It's the shape of the wave. And here we see also our little, you know, the spring going up and down. Those dots don't move side to side. They're just going vertically. And this is the complication. We have a pulse going on here compression, rarefaction, kind of, not exactly, but it's just the same concept. But within those waves are other waves. That's what I was getting at with the complications. We have waves within waves here. This is amplitude modulation, AM radio. That's how they do it. They put a signal within a signal. You have a basic tuning frequency, which is the big wave, and then they have the little waves in between are the signal. Okay, that's how that works. So it gets complicated. Of course, FM is frequency modulation that has the same amplitude all the time, but it changes the frequency like a longitudinal wave. So that's the difference between AM and FM, if you've cared. But the point is that waves can be really complicated. But it seems to me that this kind of AM is a lot like the longitudinal wave of electromagnetic waves. If so, that means those little packets or chunks got waves inside of them. So you can't say that quanta or a quantum is just a bit of stuff. It's itself a wave. So chunks of waves. And that's what I'm getting at. So apparently these, for quantum physics, these waves, these packets have waves inside of them. If that's true, then can we really say anything in nature is an actual particle of stuff? If we look deep enough, if we were able to, would we see waves or vibrations? So it seems to me that calling something a photon, like we would, that's just a quantum of light, is like cutting off a tiny bit of a string and giving it a special name. If you just think of it in terms of chunking, like some people call it chunking, actually that term is applied to language learning, which is a pretty good method. I haven't actually tried. I've looked into it. It looks interesting. But what they mean in quantum physics by these chunks is, it seems at first that they're talking about, like I said, cutting a string into pieces. It's still string stuff, but just little short bits of it that come in pulses. But I think we have what's going on here, where these little pieces are not just pieces of string, they're waves, string being vibrated. So, but if they're packets of waves, what is being waved? We still come back to this problem. Something has to be waving. Yeah, maybe that is string theory. I really don't know. I read about it, I don't know how many decades ago, was string theory. Let me get this off the screen because it can be annoying when something is moving all the time. But this is a basic idea. Sorry, I got rid of the web waves. I'm sorry if I gave anybody an epilepsy fit or something. But that's the thing, is if these little packets of quanta are waves themselves, what is being waved? What is causing the little mini waves inside those chunks? Something has to disturb something in order to make waves. What is it in those little quanta? It keeps running me in circles. I just can't answer that. I don't think anybody else can either. So where do they get the stuff that's waving? They call it little fields. But science, like I said, I mentioned Ken Wheeler, you can't even define what a field is. Particles in an area, a volume? Well, what are those particles? Little bits of waves? It's like wave inception. So let's look finally, because like I said, it's just not gnarly enough, a double slit experiment. And there's a comment here that I want to read, at least show you while I'm going to read from. Let's see, it was this guy, Gerard Bassols. If you look through that, and I don't know, I just summarize. The response by this guy, Gerard, claims that this experiment, the double slit experiment, yeah, it's an unknown thing, exactly. The double slit experiment has been done on more than just light. This is where it gets really messes with your brain, okay? Because people think, oh, it's just proving that light is waves that have these, that goes through, like you would put water. People have done with this with water, repeated the experiment using water instead of light, and you get these waves with interference patterns. But the problem is you can do this experiment with not just light. You can do it with, it's been done with electrons. Okay, just hidden message there. Concerned citizen just doesn't like bad words, but I'll let you, Maz, decide what you want to do with that. Anyway, it's been done with electrons, protons, and atoms, and you get the same results. So are electrons, protons, and atoms waves? It makes you wonder, because you can do the double slit experiment on them and get the same results as you do with light. So it isn't a property of light. That's the problem. Because here's the logical issue that happens when people do bad science. I mean, they do a good experiment and then jump to wrong conclusions, because some will say, they'll do just the light experiment, okay? And they will say, wow, we changed reality by looking at it. But that's, of course, as Will will tell you there in the chat, that's metaphysical. That's not scientific. A better conclusion is that the experiment didn't actually tell us anything in particular about the nature of light. That's the big point here. If I could say the word point, I don't know what that means anymore. But the point of my argument, at least my hangout, is that the double slit experiment doesn't tell you anything about just light. Light is not the big mystery. The mystery is why all these other things that we thought were quanta, like atoms, behave the same way as light. It's a very big puzzle. And we can't just ignore the interference patterns if we want to insist that light is made of photons. So if you take the everything is a particle or a quantum, then why does it act like a wave? And not just a longitudinal wave? Hey, Bob, a 70-second human. Yeah, that's the thing. And I watch these other hangouts and I get to investigating to try to untie some knots, and then I find how deep the rabbit hole goes, as this saying goes, and there is no end of it. I don't think we're going to get there. So in the end, if you can say such a thing at this point, I think it's all well and good to have enough understanding to make practical use of EM waves, as we do, like X-rays and optics, because I've done videos on how light works, but not how it does what it does, as far as, we can observe its behavior in certain situations like lenses, but why does it do that? We don't know. And I don't think we're ever going to reach the end of that rabbit hole, because our whole realm, I don't know if I like the word universe anymore, but the whole realm is obeying certain laws, but we can't even figure out what stuff is made of, because every which way we try to observe, and we have limits to our observation, because the farther you get from your eyes and ears, the more error is introduced, because you're using something, to examine and interpret for you. So I don't think we're ever going to get there. And it seems to me we haven't learned anything from biology when it comes to this sort of endless rabbit hole, because it used to be believed that life arose by chance and that cells were very simple bits of goo. It was believable then because they didn't know what a cell was made of. But now we know that they're very complex factories. I mean, these things are ingenious. There's robots that travel along the DNA and fix it. And there's motorized things with all the parts of a motor as we know them. Rotors and all sorts of things. And it's just amazing. There's some really good animations you can find on how cells work, how DNA is repaired. It's a factory. And life is just not simple. It's designed. So if we can't figure out those things that we can see fairly well, how are we going to figure out electromagnetic waves, and when we can shoot atoms through the double slit experiment and they come out just the same way light does? We're not going to solve this. All we really know for sure is that this was all designed by a powerful, intelligent being, and those attributes of power and intelligence can't ever arise by chance. That's what we know. Eternal regression theory on one extreme, where you go back into time and think you can do this endlessly as if it answers any question, which it does not. It simply evades the question. Or the other extreme of we're in a simulation and there's some alien kid in his basement, playing sim games that we are it. And then there's somebody above him and somebody above him and so forth endlessly. Those don't answer questions. Those are evasions of questions. And what they're evading with these eternal regression, or either in time or into more and more evolved beings, whichever way you go with that, what they're evading is the horrible thought that there might be a God after all. And that's what it all boils down to. That's why they're searching so hard to figure out how the mechanics of things work when they're not even mechanical at the electromagnetic level, and trying to figure out what causes what. They'll never get there, and they themselves already know they won't, because they believe in eternal regression. Whether it's, again, the sim theory or the going back into time, they just don't want to believe in a first cause, no matter how close or far away, how many steps you take to get there. They don't want to ever get there. And that's the purpose, and plus it keeps the funding flowing, of more and more and more trying to split the atoms and split the subatoms and try to figure out what, these quantum things, which, like I say, they got fancy names for ether now, which is quantum fluid or something like I mentioned before, but they're never going to get there. And so when somebody gets really upset, whichever side of the particle versus wave argument they want to be on, it seems to me they haven't seen the big picture here, because the big picture is endless, because God is eternal and infinite, and they're never going to figure it all out. They will keep searching forever and raise more questions than they had started with, just like with biology, where they thought everything was fairly simple and would be solved shortly, in a few generations, and it's only gotten orders of magnitude worse. The same thing will happen with the subatomic level of things, the non-biological things. So exactly, that's a good verse. Always learning, but never able to come to a knowledge of the truth. That's people are just evading. Like I said, they don't want to face their creator. So I'm pretty sure I didn't solve anything, or I tried to explain what I understood from trying to scavenge for physics explanations of these things. But the problem, again, is that we really don't know how things work. We can, do a lot of amazing things with what we know so far. You can use electricity without knowing how it actually does what it does. And then that you get into, such as, Edison versus Tesla, as far as how electricity works. Again, Ken Wheeler, Eric Dollard, people like that will tell you about, that we've got our whole electrical theory wrong. And that's probably true, but it still works. It still works. It's just like I can drive a car without knowing how the engine actually does what it does. I have the vaguest idea, but I couldn't fix the thing or anything else besides the engine and all those, tubes and things all over the engine. I couldn't do that, but I know how to drive it. I know how to make use of a car. And in the same way, science, empirical science, actual practical science, can do useful things. That's what engineering does. But when it comes to this theoretical stuff, and they're trying, again, to get rid of God by thinking that if they endlessly run the treadmill or the hamster wheel, that they're making some kind of progress, when all they're doing, like I said, with biology, is raising more questions the farther they go. It just gets worse and worse and less understandable, and more maddening, if you ask me. Because like with this double slit, like I said, this guy is saying this has been done. It isn't just light. It isn't light alone that has this weird property. It's just about everything. And we don't really know if everything is made of waves. And if it is, even those quanta, if they have little wave sets inside of them, what is the material that is being disturbed and what is disturbing it? Nobody knows. And they can't know. I don't think they will ever be able to know. That's not to say they shouldn't pursue stuff that interests them. I'm all for that. But they have to be realistic and know that there's no end to this. And again, to try not to be dogmatic about how things work, because is it a particle? Is it a wave? How can things wave without particles? It goes in circles. It's maddening. So let me get back, try to look at the chat on, I think something Will said, I forget what had to do with, he said there's the one about the slinky. You know, I might as well go all the way back as far as I can run this and see what we got here. And we have Pillbox and somebody's name I can't say, TS, something spin, Deb Jones, Journey's Wake, Ryan Q. Vincent, Mark Bailey. And if I repeat, sorry. Let's see who else we got here. I'll try to also look at questions or anything as I go along. Yeah, Wi-Fi is just another form of radiation. It's radio waves. Ether would be the space we live in. Yeah, if it exists, we can't detect it. We can kind of surmise that it's there, but we can't really observe it. It's a good explanation, but like I said, you know, sometimes we're begging the question as much as the other extreme is. So I don't know how to answer that. But yeah, we'll have to, Mark, back to your question about the Discord channel. We'll have to wait till we can get our other channel to run sometime, and we'll discuss that, I guess. Yeah, light goes through different mediums, but it goes at different speeds, which is why lenses do what they do. And you can see my challenging standard cosmology, the sun video on that, on the lensing. Also, there was one I did about mirages. I forget what I titled it right now, but that one had to do with lenses also. Rocket thrust in a vacuum. No way to really test that. I mean, somebody needs a vacuum. There's a guy who does all these tests in the vacuum chamber. He has a little box at home. He puts all sorts of neat things in the vacuum chamber. I don't know whether he's ever tried to run a rocket, but the problem is the chamber isn't big enough. The rocket thrust is going to go out if it ignites inside the rocket with enough oxygen to make it ignite, it's going to definitely have a force that is directed outward, but it'll eventually hit the edge of the vacuum chamber and could account for some pushing force. So I don't know. I'd have to think about that. Let's see. Earth being a realm. Yep. That's the best way to describe it. I think Tesla described it that way too. Okay, there's the comment I was looking for. Will says, I've come to more or less regard the ether as basically being a hyperdimensional medium or spiritual layer of reality. I can read better and I can talk. I think that's kind of what Eric Dollard was alluding to. If he's really hard to understand, so I don't know. And sometimes you don't know whether some of these people are crazy or brilliant or both. But hyperdimensional works as well as anything else. I mean, if they can say quantum physics and do their metaphysical mumbo jumbo, then so can we. But anyway, I don't think we're doing that to any degree like they are. But if ether exists and it seems to explain a lot of things, I don't think we can know what it's made of. It's like what I consider that I've heard people describe the brain as a machine that a ghost can operate. I think of it as an interface between the soul and the body. And that's why there can be such a thing as brain death. When you think about it, if all the biological parts are there, the chemistry and the electricity and the oxygen and blood and everything, the brain should be thinking. But there's people who have all those things and the brain is not doing anything. They can't explain that other than saying that there's something that isn't there anymore, and that would be the soul. So it could be that the ether is itself an interface, and that's, I think, what Dollard was talking about when he said that the sun was like a portal or lens for the ether, that there's something happening on the other side that causes that spot in the ether to emit light and heat. So I think we're on the same page there. EM can move through it, but also interact with our physical reality. Yeah, obviously. I mean, it's weird. EM waves are weird. And that's why I think they're, the argument between whether light is made of photons or waves will never be solved. And it's kind of silly to take a dogmatic position on either side. Yep. agree, Deb. He's got excellent videos. I just know how to talk and show pictures. I don't know how to actually make entertaining videos. I can't imagine how people do that, but yep. Let's see. Using the slinky as a medium in that example. Yes, the slinky is the medium. And like I said, if you have a longitudinal wave, especially with EM theory, you have to have EM stuff from start to finish in a line that's being compressed and rarefacted, because otherwise you don't have a wave. And yet it is a wave. They call it EM waves, or waves of light, or waves, radio waves. I mean, it's just begging the question. Like I said, it's its own medium, but even within those packets, there's waves. So go figure. You know what? It's almost like, like I showed that picture of the amplitude modulated wave, and also there's FM would be frequency modulated. It's more like the frequency modulated, but within the signal is telling you again that there's a language even to the inanimate parts of the universe or the realm. And where there's a language, there's a coder and a decoder, and that would be God. I mean, you can't have those kinds of languages without an intelligence. So again, everything, no matter how they quantify, it is designed. Let's see. What else we got? Oh, I forgot to keep naming people as I'm scrolling. And we have Chow, Concerned Citizen. Yeah, string theory. I don't know. I'll take your word for it, because I haven't really looked into string theory in such a long time. I don't remember what it was about, but I think they were little mini vibrations. But here again, there have to be maxi vibrations between the mini vibrations and in a line from start to finish. And what instigates the wave in any case? The encoded wave. That's basically what an EM wave is an encoded wave. A wave carrying information and not just energy. Let's see. Yeah, and that's what vibration is. Excuse me. People talk about raising their vibrations. And those are the people who seem to think that the best way to raise them is to lower them by F-bombing and whatever else they're into. But people are inconsistent. Let's see. Field is just a term they settled on. Yep. Unknown thing. It's a volume of stuff, and we don't know what the stuff is or how it works, but it's a volume of stuff. Yeah, when it comes down to it, they really don't know much more about reality than we do. Let's see. Atoms act like light. That's what this guy was saying that I've had up here on the screen. That I'm taking his word for it, but I'm sure if I looked, I could probably find this stuff. That they've done the double slit experiment with things besides light. I know I've seen the ones on water, but when you do it with atoms and they split up and act like more atoms were made and they're waving instead of particling, it messes with your head. Let's see. What if they are actually shooting other forms of EM and not atoms? Yeah, why not? Like I said, we could find out in the end, if there is no end really, but that, regarding the string theory idea, is that everything is made of little sets of vibrations, little code bits. It makes as much sense. And then they'll say, oh, we're back to simulation theory. And I'm like, no, we're not, because this is our reality. It's just designed. What they call simulation is obviously designed. I mean, that's what a simulation is. There's a designer. And the problem is not a question, really. We know why. The problem is pride. They don't want there to be a God. And so they try to make up other excuses, like evolution is the magic wand that turns frogs into princes, because you have enough time. Anything can happen, no matter how counterintuitive, no matter how magical. Anything can happen if you have enough time. But time is not a thing. So it's just like trying to bend space or time and calling it space-time just because Einstein did and made up an oxymoron, or whoever actually made up that term. As Tesla said, how can you bend nothing? If space is nothing and time is immaterial, how do you bend those? You can't. It's stupid. It's like the emperor's new clothes. That's basically what scientism has devolved to, the emperor's new clothes. Yeah, they will never figure it out. The theist studies anything nature in this instance glorifies God. The atheist studies it and glorifies first man for discovering it, and second, nature for its diversity and ability to change. Well, that's design, right? I know you guys all know that. It's designed. It does what it does. It adapts or whatever it does because it's designed to do that. So they cannot escape design. Let's see who else we got here. The chat keeps moving on me. We have Z Proxy, 72nd Human. Karen B. I think I mentioned Chow before. Rich Bub. Oh, thanks, Deb. That was a very nice thing to say. Let's see, I get worn down. Can't figure out how to make a step-up converter yet. I like, yeah, that sounds like, what they called it, fundamentals of electricity or something like that. I remember from way back, I don't know, a long time ago in the early 80s. Yeah, we had to build power supplies and things like that and work with all those diodes and discrete components. Those were fun. Now everything's so tiny, you can't just go to Radio Shack and buy stuff. I was happy to just work with 5 volts. We had at one point in school on one of our labs to build an oscilloscope with these tiny little cathode ray tubes, and there was caution all over the place that you could actually kill yourself and electrocute yourself working with these things. So be careful because it takes so much high voltage that I didn't like that part of it, but I was happy to stay in the 5 volts to 0 realm. 12 is okay. You can't really hurt yourself too much with 12, although I got myself a good shock once or twice. But anyway, it's a trip. It's interesting. I always said, I did my programming degree first and said, eventually I got too curious about how the machine was doing what I was telling it to do. I needed to know, and I went back to school just for that, to study electronics. And when I got out, I was like, you know what? I don't even care if I get a job in this. I'm happy to know what I know. And that's the thing about science education. People want to throw the baby out with the bathwater. They're becoming, conspiracy theorists in general are becoming superstitious because they're afraid of science now. And they think they want to do science and defeat the bad science, but then they throw out everybody who's got any kind of science education unless they're telling them what they want to hear. So it's a mess. Let's see. I think I mentioned concerned citizen. Let me scroll up the chat again because it keeps skipping on me. Fun with sound. That sounds interesting. Journey's Wake. Thank you. I'm sorry I missed you saying goodbye. I don't know if you're still here. All right. I think I'm caught up now. I'm really happy you guys came. And like I said, I don't know if I answered any questions actually, but I raised some. That's what I do. I just mess with people's heads because everybody's messing with mine. And I read this stuff and I hear people arguing about, waves versus quanta and all sorts of, issues of gravity. And because there's implications for these basic physics. And so I go try to look for some way to distill the information, but you have to understand it first. And then you come away from it going, I know less than I did when I started. So it's very frustrating, but I think it's worth the try. And some of those illustrations were pretty neat. So there you go. I don't know what else to say. I think I've been going for about an hour now. I'm sure there's got to be other things to do on a Friday night, but I like to, when I, for whatever reason, I get what I call a download, whether it's theology or science, and I have to write it down. And I keep, when it flows easily like that, it's a download, and I have to play it back. That's how I understand stuff, is if I can play it back and explain it to someone else, then I have some kind of grip on it. And it seems to stick better in my head that way. And that's just how I do stuff. And I've known in the past when I was just, writing on my blog, if I tried to write just for the sake of writing, it was like trying to run underwater. So when the inspiration strikes and when it doesn't, and so it struck me. So here I am. Let's see. Interesting. Yes, thank you. And yeah, there's no end to the rabbit hole. I'll just tell you that. Nobody knows how deep it goes because it's probably infinite because you can't outthink God. All right. That's all I've got. If there aren't any more questions, I'll probably just end it here. And we'll see y'all later. Thanks for coming.